Yes. So I think within the last week they just released their 3D grapher. So you used to not be able to graph in three-dimensional things in using Desmos. So it's their beta version of it. I just want to let you all know it's there. If you go to Desmos, click on Desmos. Up here it says Introducing Desmos 3D Beta. Try it now, and it takes you there. So this is not going to be. I'm going to try and use it a little bit in here. We're going to be doing something later where. Take a look at this, where we take that's not it. Where we take a function, right? We're going to take a function, that's our normal function, right? And we're going to wrap it around the x-axis like this. And we're going to look at that, as like a solid and try and find its volume. So just the ability to graph in 3D used to not be available in Desmos. So I just want to show you it's there. I'm going to use this a little bit in my Cal 3 class. We're going to be doing things. Oh, hold on. This was me just messing around with stuff. Hold on. No, where is it? There we go. I know that looks complicated. So what you see here is you see a surface. See that red surface, and you see that cylinder. What we do in Cal 3 is we try and see if we can come up, God dang it. We try and come up with the curve where those two intersect one another. So take these out. See that curve right there is the intersection of that surface and that cylinder. And we try and find like that path, if that makes sense. Anyway, I just want to let y'all know, Desmos now has that 3D capability. All right, so what are we doing today? We are continuing partial fraction decomposition. I started to go through it last time. We did, I think, a few examples, right? And the big takeaway, I guess, from last class was actually two things. If we have a rational expression, and we're trying to integrate it, find the antiderivative, then we're going to need to first compare the numerator and denominator degree. If the degree of the numerator is bigger than or equal to the denominator's degree, we have to do long division first, right? And then after that, we look at it, we look at what we're left with, and then we look at the denominator and we factor it. And we look at those factors and we see what to do with that, right? And all I've shown you up to this point is what happens when you have distinct linear factors on the bottom. So now, today, we're going to go into something a little more complicated. So we did part A. We did that in class. We ended our lecture. And I'm sorry, I just posted that lecture this morning. I forgot to take my SD card home with me. So we're going to do this problem next, right? We're just going to go in this order and just kind of, as we need more partial fraction decomposition techniques, I'm going to introduce them as I go. All right, I told you all before, I'm going to act like you haven't seen it, but I'm just going to teach it as we go. All right, so here we go. We've got this pretty ominous looking integral. All right, so I'm just going to check real quick before I even start doing partial fractions on this. I'm going to check real quick to just see if maybe I'm going to get lucky and just a basic U sub would work. And the reason I'm thinking U sub is because the degree of the denominator is the third degree polynomial, and the numerator is squared. By the way, I should point out, I'm not doing long division. I'm already ruling that out. Why? Because this is smaller than this, right? If this was bigger or equal to this, I would do long division first, but because that's not the case, I'm not even thinking long division right now. But I am thinking maybe if I let u be the entire denominator, right, then the derivative of that, maybe it's that. I'm just going to check. I don't know. U is 2x cubed plus, this would be really fortunate for me, wouldn't it, if this worked out? It's probably not going to work out. 6x squared plus 6x minus 2 dx. Do you all agree that's our derivative? And you could pull a 2 out of this, right? You could pull a 2 out, and you'd be 3x squared plus 3x minus 1, right? But see, this right here is not the numerator. Now, remember, there is a method that I showed you where we make it happen, right? Where we forced it to happen. I told you it was a method that I use that, if you go to a tutor, they're probably gonna be like, what the hell are you doing, right? That. So I'm not going to try that here because I only try that when this is quadratic and this is linear. Quadratic and linear, that's when I can kind of massage it and make it be what I need it to be. It won't work when you have something like cubic and quadratic, all right? So this doesn't work, everyone see? Fails? Okay. Thank you. All right, so what am I gonna do? Well, I'm gonna try partial fractions. And again, I'm not doing long division, so I'm gonna just first look at the denominator, and I'm gonna factor the denominator. All right, so 2x cubed plus 3x squared minus 2x. And first step of factoring anything, GCF, greatest common factor. So do they all have something in common? X. So I factor an x out. And now I hope that that will factor. And it does. Okay? Does that factor? Does it? 2x, let me see, x, we got to make this work right. That work? 2x squared, 4x, take away x, take away 2, right? So I am assuming all of you can factor, right? Just maybe take a little more time, yes? You could get this? Okay. So that's the way the denominator factors, right? Okay, now we come back here and we say, all right, I know I can rewrite this as integral x squared plus 2x minus 1 over those three factors, x, 2x minus 1, and x plus 2 dx. So I'm trying to solve that now. The whole point of that, the whole point of me doing that factoring technique is to now be able to identify my factors. I need to know how many of them I have and what type they are. All three of these, there's three, right? All three of these are linear factors, right? Linear, linear. We have not had anything other than linear yet, right? I haven't shown you anything yet. It's coming, all right? These are all linear and they're distinct. Distinct, what do I mean by distinct? They're all different, right? They're all different. There's not like the same thing repeated, all right? So that's called the repeated linear factor, and we will see that as well. So these are all distinct. And distinct. Looks weird. All right, since they are different, right? They're distinct. What I'm going to do, here's my scratch work now. Here's my partial fraction decomposition step. I'm going to write the original integrand, right? I'm not working with the integral sign right now. I'm just going to do some algebra over here. So I'm going to take this, and what I know from last class is if I have three distinct linear factors, then I know that the partial fraction decomposition of this will have three fractions, a over the first distinct linear factor, plus b over the second distinct linear factor, plus c over the third distinct linear factor, right? I know that because that's the method. The method says if you have three distinct linear factors, you're going to have three fractions. A on top, B, A on top of the first one, B, and then C. So what we need to do now is figure out what A, B, and C are. And just imagine that if you knew what A, B, and C are, right? If you knew what these numbers are, then it would be pretty easy to integrate this, wouldn't it? Because this would just be constant over linear, constant over linear, constant over linear, and those we know how to do from the previous parts of this section, right? So how do we find them? Well, y'all remember what we do? Multiply both sides by this. Okay, so on this side, multiply by x, 2x minus 1, x plus 2. Okay, and then it'll go away, but then you have to do it on this side as well, right? When we do it on this side, it distributes to each one of these. So you'll have an x 2x minus 1, x plus 2 here, x, 2x minus 1, x plus 2 here, and then x, 2x minus 1, x plus 2 here. I'm kind of not showing the step of, I'm just distributing it right now. So on the left side, we have just the numerator. And on the right side, when we multiply this blue piece times this, the x's go away, right? But we're still left with the a, and we're still left with 2x minus 1, and we're still left with x plus 2. On the middle term, the 2x minus 1 cancels with the 2x minus 1 on the blue one. So here the x went away. Here the 2x minus 1 goes away. So we still have the b, we still have the x, we still have the x plus 2. And then on this one, the x plus 2 factor goes away, and we get plus c, we have the x, and we have 2x minus 1. There we go. And this is kind of like the master equation I'm going to work with the rest of the way. Now what I do is I have to be a little bit clever, and I have to figure out what to plug in for x to make certain things go away and certain things stay. So I always just go in order. I'm going to try and go after a first. So what I do is I look at the factors here, look at the factors over here, and I try and figure out what factor do I have here and here that I don't have here? X. Okay. So if I have x here, how can you make x equal to 0? What would x have to be to make x 0? 0. So I just let x be 0. And now I rewrite this entire equation, replacing all the x's with zeros. So 0 here, it goes away, right? And you just get minus 1 equals, okay, a. Careful on this step. 2 times 0, minus 1. Negative 1. Put it in parentheses because it's being multiplied, right? Not subtracted. 0 plus 2, 2. Right? And then here, b times 0 times who cares, right? This is all gone. And this is gone as well, right? That's the whole point of doing it, right? So what do we get here? We get negative 1 equals negative 2a, and divide both sides by negative 2, and you get a is a what? 1/2. Right? A is 1/2. That makes sense, everyone? All right, now I've got a, right? I've got a. Now let's get b. So I look at b, and I say, okay, what factors do I have here and here that I don't have here? The 2x minus 1 factor, right? The 2x minus 1. So what would you have to let x be in order to make 2x minus 1 be 0? 1/2, right? You can just, you're asking yourself, when is that 0, right? Just solve it. It's just a little linear equation. X is 1/2, right? So I'm saying, okay, now I'm going to let x be 1/2. If x is 1/2, and now this is going to suck a little bit because we're working with fractions, right? But we can do it, right? Plugging in 1/2 into this entire thing here. All right, what's 1/2 squared? 1/4 plus 2 times 1/2, 1 plus 1 minus 1, right? Equals, okay, what's going to happen to this piece? It's going to go away, right? Because when you plug in 1/2 right there, it should clear everything out. So that's all going to go away. This one should not, right? The b should stay here. I'm replacing x with 1/2. And then what's 1/2 plus 2? 5 halves, 5 over 2. So 1/2 plus 2 is the same as 1/2 plus 4 over 2, right? And that's 5 over 2. Is that all right? I'm not showing that? 5 over 2. And then plus, when we plug in 1/2, we already know that this is going to go to 0, isn't it? So that's all we have, right? So that becomes, let's see, the 1's go away here. We just have 1/4 equals, all right, this is multiplied across 5/4 b. What now? Multiply by 4/5, or you could say divide by 5/4. Either way, you need to get b by itself, and I trust that your Cal 2 students, you could get b as what? 1/5. All right, we got 2 of the 3. All right, bless you. All right, last one. We need to see if we can find C. To find C, we look for whatever factors are over here that aren't over here. So x plus 2, right? So what would it take, what would x have to be to make x plus 2 be 0? Negative 2. So now I'm going to replace all my x's with negative 2. Okay, here we go. Negative 2 squared, positive 4, right? Plus 2 times negative 2, minus 4, right? And then minus 1 equals, okay, this should go away, right? Because when I plug in negative 2 here, that's all gone. When I plug negative 2 here, it's all gone. And then I need negative 2 into this. So C times negative 2, and then let's see, 2 times negative 2, negative 4, take away 1, negative 5. What's the left side of that equation? Negative 1 equals, okay, 10C, positive 10C. And that means C is negative 1/10. There we go. All right, we're in business. So now this integral becomes the integral. I can break it up into these 3 fractions. I know what A, I know what B, and I know what C are. And I told you when you write this, don't overcomplicate it. Just put the number on top because we're going to pull that out anyway. B was 1/5. Just make sure you get these on top of the right thing. If you can't just, like, you have to pay attention to where they're placed, and what the A is over, what the B is over, what the C is over. That's important, right? So x plus 2, and then C was negative 1/10 dx, like that. And the whole idea is that this should be doable, right? We should be able to get this. So let me go one more step. I'm pulling the 1/2 out. I have 1 over x dx. I'm pulling the 1/5 out, integral 1 over 2x minus 1 dx. I'm pulling the minus 1/10 out, integral 1 over x plus 2 dx. You see, that's what we're really doing. We're breaking into 3 separate integrals. We're doing each one using what we learned way in the beginning, which is, all of these should involve what? Antiderivatives. What's going to be our antiderivative? When you have a constant over linear, you should have a natural log. Okay, so this first one is just 1/2, and then that's just natural log absolute value of x, right? I'll do a plus c at the very end. All right, let's do the last one, because the middle one's a little tricky. Here I get negative 1/10, natural log absolute value of x plus 2. I'll go ahead and put the plus c out here. All right, this one's the one that's a little bit tricky. What's the tricky part? The 2 in front of the x. This is linear, right? But remember, when we have, anytime we have like ax plus b, we have to scale it, right? So I'm going to have to put a what in front here? 1/2. And then you can do the natural log absolute value of 2x plus, minus 1, sorry. And then minus that. And then these two come together and become 1/10. That's it. That's our answer. What do you think? It's all right? These are the easy ones, because it's just, these are all just, we have 3 distinct linear factors. So there's nothing crazy. We can figure out what, just let x be this, 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 and then we get our 3 answers. We're going to have to see one that's not so nice, all right? So let's go to the next example. Oof, these are just starting to look worse and worse. Okay, check that one out. All I'm doing are examples today. So I brought some examples from some old tests to do if I can get through these. Just problems I pulled off exams that you can see, like some things I've asked in the past. All right. I think on an exam, this is pretty obvious that this is going to require partial fractions. Would you agree? Like if you saw this on a test, this should be like a big, like, red flag. This is probably partial fractions. All right, what's first? Look at the powers, right? See if you need long division, do we? Yes, because the degree of the numerator is bigger than that. What if it was a 3 up here? Would I do long division? Yes. Okay, it's only if it's smaller that you don't. So long division, let's do that. Let's do long division right here. Okay, so I'm going to do long division first. All right, and we love long division. So I'm going to division box. In the division box goes the numerator, right? Don't get them backwards. X to the 4th plus, I don't have an x cubed, right? So I'm putting 0x cubed so that I have a placeholder for any x cubes just in case I get them. Minus 2x squared plus 4x plus 1. So anywhere that we're missing one of those powers of x, we need to put it in there. And then on the outside goes the denominator. And of course, these are always written in descending order, right? Highest power of x down, both inside the box and outside the box. And now we get to play our game where we try and turn x cubed into x to the 4th. And to do that, I have to multiply x cubed by x, right? And I told you in class, you can put the x up here anywhere you want. Some people, they tell you line it up. It doesn't really matter. I'll line it up, though, just for fun. So this is going to be x. And now I multiply x here, 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 and put those terms under the appropriate columns. Why do y'all hate long division so much? Everyone doesn't like long division. Is it too complicated? Like, it's tedious.
It feels like it's we have calculators now.
Yeah.
It's so long in elementary school and middle school dealing with this crap, and now we have
Yeah.
calculators, so I'm just like, why am I doing this?
Well, but calculators can't do the long division unless you have a symbolic manipulating calculator, right? Like you can do long division, yeah. But doesn't this seem like relatively not that bad anymore, like relative to everything else you have to do, right? This is just like a little...
It's just a lot of little steps to remember on top of all these integrals.
Yeah. A lot of places you can go wrong. A lot of places you can go wrong. That's the big thing, I think. You mess up one sign and the whole problem's off, right? Okay, so x times x cubed, x to the 4th. That's why it's important you show your work on the test. X times negative x squared is negative x cubed. I look for little mistakes, and if it's minor, as long as the rest of the work you did is good, I take that into account. We're all human. Okay, so y'all understand I just multiplied x through to everything over there, lined it up, and then the big step, subtract, right? Change the signs. If it was minus, make it plus. If it was plus, make it minus. Oh, I forgot to...
Why was the original x cubed negative that you put there before you made it to a plus?
Because when I do x times negative x squared, I get negative x cubed.
Oh.
Then I'm doing x times negative x squared gives me negative x squared. Sorry, x times negative x gives me negative x squared. And I forgot to put the plus on this one. This should have been a plus, right? That should have been a plus, and now I'm changing it to a minus. And now add down. So what do we get? Nothing? X cubed, negative x squared, 3x positive, right? And then finally, that's really a 0 here, plus 1. Okay. All right, now we try it again. We see if we can now turn x cubed into x cubed. Can you turn x cubed into x cubed? Yeah, multiply by 1. So I put plus 1 here. And then I take 1 and I multiply 1 times each of these. And that'll be pretty easy because that's just the exact expression right there, right? Okay, x cubed, I put that underneath here. It'll be positive x cubed, it'll be minus x squared. It'll be minus x, and then plus 1. And then change the signs, right? Change the signs. So this becomes a minus, this becomes a plus, this becomes a plus, and this becomes a minus. Add down, these go away. Oh, those go away. These don't. 4x. Is it just 4x?
Yeah, that's what I got.
It's just 4x. Everything else cancels out. All right, questions? We're not done, right? We're just, long division's done? Okay, so what this says is that this is like our remainder, right? And we need to check, can we turn x cubed into 4x? No. So we're done, right? This is the remainder. So what I do now is I put plus the remainder over what? The original divisor, this right here. I've got this thing in the way. X cubed minus x squared minus x plus 1. So what we're saying is that this big ugly expression, right? This big ugly expression is the same as that expression. They're the same thing. So I'm going to integrate that instead of integrating this, right? So now my integral becomes the integral of x plus 1 plus 4 over x over x cubed minus x squared minus x plus 1 dx. Right? That's where I am. All right, now I've got it broken up into 3 different terms. That I can integrate, right? Power rule, that I can integrate. This I need to now focus my attention on, right? This. This is a rational function. And I know I don't need long division because that's how I got here, right? So I need to now stop, okay? I'm going to stop here and I'm going to go do some more scratch work. I'm going to try and do partial fraction decomposition on that piece. So more scratch work over here. This is my partial fraction decomposition. And what I'm trying to decompose is the 4x over the x cubed minus x squared minus x plus 1. But in order to do partial fraction decomposition, I must factor the denominator, right? So how do you factor this? Is there a GCF? No, no GCF. How do you factor something like that? How many terms do you have? 4. When you see 4 terms, grouping is what we try. We hope for grouping, right? Grouping is the technique. So should we do scratch work for that or no? I can do scratch work for that. Let me do that. Okay. Scratch work, factoring by grouping. Okay, so I'm taking x cubed minus x squared. Does grouping always work? No. What if grouping fails? Do you all know what you can do? Try. It's called the rational zero test and synthetic division and all that stuff. Yeah. Yeah, but with synthetic division, we do it with the box with just the numbers. It's much faster. Fortunately for us, this is going to work. Grouping is going to work here. So, oh, and I'm not going to give you a problem where you have to use synthetic, right? It'll be, grouping will work. I'm not nice, but I'm not that not nice. Okay, so grouping, what do? For grouping, we look at the first 2 terms and the second 2 terms independent of one another. So here we see if we can pull a GCF. They both have an x squared, right? So we pull a GCF out of there, and that leaves us with what? X minus 1, right? And now what we need for grouping to work, we need to be able to pull something, a GCF out of both of these, so that what we get here in parentheses when we pull something out is exactly the same as that, x minus 1. So can you tell what we would need? -1. You'd need to pull a -1 out. And the whole goal of grouping is to make sure these 2 things are the same. Do you all agree that this is the same thing? If I distribute here, here, and then here, here, it's the same thing, right? But if these 2 things match, then the next step is we can take the x minus 1 and pull it out as a GCF, as x minus 1, and then in another set of parentheses will be the 2 factors that we had pulled out of each of those parentheses, x squared minus 1. That's grouping. Okay, that's a review. Okay, you all took college algebra and passed, so you're here. That's a review of grouping. If you need to go review more, you can. All right, one more thing. Notice on this is the same as x minus 1. That's a difference of squares, isn't it? That's x plus 1, x minus 1. That's a difference of squares. So I can write it this way. And do you all see that we have 2 factors that are the same? Right? Okay, so now when I come over here, I'm going to do my partial fraction decomposition. Let me erase this because of the space I need on the board. Let's see. I'm going to write this as x plus 1, and then this one, x plus 1, oh, sorry, x minus 1 squared. I just rearranged. Is that all right with you? X minus 1 times x minus 1 is x minus 1 squared, and then x plus 1 is just x plus 1. So what I'm going to notice now, and this is the first time we've had this, is that this right here is a linear factor, right? This right here is a linear factor, right? But it's what? It's repeated, what we call repeated. It's repeated because we have the squared. And we deal with repeated linear factors different than we deal with just linear factors, single linear factors. And this is the partial fraction decomposition step that I haven't talked about, so now I'm going to talk about it, right? So for this linear factor, right, we deal with that first. We say, okay, well, that's going to be some number on top of that linear factor. And that's the same as what it was before. But with the repeated linear factor, here's what we do. We say, all right, I'm going to have a b over that linear factor, all right? That's the same so far, still the same? But I have to do an additional c over that linear factor squared. All right? You allergic to partial fraction decomposition? Oh.
Get two, but she gets as many as she wants.
Well, I was about to say everyone's going to be sick. Like everyone's going to get sick because all I hear is sneezing coming from you all.
Don't put that out there. Don't put that out there. It's too close to midterm.
I know. So this is repeated, right? So we go b over that linear factor, then c over that linear factor squared, all right? If this had been a 3, I would do b over x minus 1, c over x minus 1 squared, plus d over x minus 1 cubed. I would have 3 of them. If it were a 4, I would have b over x minus 1, c over x minus 1 squared, d over x minus 1 cubed, e over x minus 1 to the 4th. Understand? As far as you need to go. But fortunately for us, it's just squared. All right? That's all in the notes, but I think verbally it's easier to explain. Right? Any questions on that?
So that's linear over repeated linear?
No, we don't care about the numerator. All we care about are the factors. When we're at this step, we're ignoring this completely. All right, so now we're going to do the same thing we did before. We're going to clear the fractions, right? We're going to multiply both sides by this, all right? Okay, let's do it. So I'm going to multiply this side by x plus 1 times x minus 1 squared. And then I got to do that here. X plus 1